Hello, this is Isa and I's project for week 5. In this video, I'm going to be explaining our one sample t-test. So for this one sample t-test, we were required to research the average height of either a US boy or US boys or US girls, and in this case we chose US girls, and compare that with our own sampled girls, which would be 20 girls. So below we have the histogram, which as you can see has all of our data values in order, and you can see how many of each were collected in our survey. Below is the average height of girls in the United States, which was 162.56, and our citation for this average height is right here. For our hypothesis, our null hypothesis would be that our surveyed girls would be equivalent to the average height of US girls in the United States, and our alternative hypothesis would be that our surveyed girls is actually less than the average height, which is again 162.56. Our alpha or significance level is 0.05, and in order to conduct further tests, we need to check if all conditions were met. So for the first condition, the randomization condition, all heights of the girls were randomly selected and sampled, so this condition was met. As for the independence condition, we can assume that the probability of one girl's height cannot directly affect the probability of another, therefore they're independent groups, and the condition is satisfied. For the 10% condition, we can assume that the sample, which was only 20, is less than 10% of all females in the United States. So that is satisfied. And for the nearly normal model, we can assume that our histogram is roughly unimodal and symmetric as seen here. And that condition is met as well. So all conditions are satisfied, meaning we can use the t-model with the 19 degrees of freedom to do a one sample t-test for the mean. I will now pass this over to Isa Long, and she will be explaining the other half of the one sample t-test. So within this project, we are dealing with a one-tailed test, and these are the statistics that we collected. So for the mean of the group members' data, x, it equals 156.46, so that was the mean of all the data values we collected. And the average is located right on the top, which is 162.56. Our standard deviation for our data values was 4.6178, and our sample size is again 20. So here are the mechanics, basically finding the t-score, the p-value from the t-score and the degrees of freedom. So our t-value equaled negative 5.908. Here's the formula right there. And our p-value ended up being 0.00001. And our degrees of freedom, which is n-1, equals 19. So this is the drawing we used. We decided to illustrate our t-score within the diagram. Here you can see the 95% in the middle, and then the rejection zone, which shows 5%. So we use only this tail though to show our values. So negative 5.908, which is our t-value, would be located in the rejection zone because it is lower than our critical value, which is negative 1.729. So since the p-value is less than 0.05, which you can see right here is 0.0001, so since that is less than 0.05, and our t-score, our t-value, which is negative 5.908, falls within the rejection zone of the drawing, there is enough evidence to reject the null hypothesis. So to interpret this within our context, there is strong evidence to suggest that the mean of the group members' data of our data of the girls' heights is lower than the average mean of girls' heights in the United States. So as for the 95% confidence interval, these are our mechanics. These are everything, all statistics needed in order to conduct the confidence interval. We restated our mean, our sample size, our standard deviation, our t-value, our SE value. So you can see right here is 1.0594. In order to find the 95 confidence interval for one tail, we would use 0.05 and locate that on the t-table to find our critical value. So, or you could plug it into like a calculator. online or something, and we got 1.7291, which was stated before within our drawing. So then we did our mean plus or minus the critical value multiplied by the SE value. So you can see here for the plus we got 158.29 and for the minus 154.63. So those values would be our confidence interval. So it would be 154.63 and 158.29 is our 95% confidence interval. So basically concluding with this statement is there is 95% confidence based on the data that the interval contains the mean height of female heights that were gathered, and 95% of all such random samples will produce intervals containing the true mean height. And that is it for our project. Thank you for listening.